Now we're going to look at some of the applications, sometimes called story problems, that are used to apply the quadratic solving processes that we've learned from the quadratic formula or factoring, any of the different methods we've used to solve. Now, this is just a translation problem, really, and then you have to solve it. So just like sometimes when you're translating from one language to another, sometimes you have to translate one word at a time, almost with a dictionary, and sometimes you are a little bit more fluent and you can read it and think about it and translate maybe phrase by phrase. But where there's errors on these are typically in the translation. So let's slow down and talk about the translation as we move from English to math symbolism. All right. Now we look at this problem over, and it says the area of the rectangle is 84 square centimeters. What are its dimensions? So read it over. You have to read these like 3 or 4 times. So read it over first to get an idea of what you're doing. Read it over again to start trying to figure out the translation. So I read it over and thought, okay, this is a geometry problem. Look back at it and go, what kind of geometry are we talking about? We're talking about areas of rectangles. What do I know about areas of rectangles? Well, the area of a rectangle is the base times the height, or the length times the width, however you phrased it. So they've told me that the dimensions are x plus 3 times and x minus 2, so I know that if I multiply those together, this would be the area, right? This would be the base. This is the height, or you might think of it as the length and the width. But this turns out to be 84. Now, the problem with this is we don't know what multiplies to 84. It could be 4 and 21. It could be a half and 168. There's a lot of combinations, 1 and 84. So what we only know is what multiplies to 0 sometimes. And maybe even then we don't know, so we have to use the quadratic formula. So what happens is if it's not equal to 0, you have to reconfigure it, multiply it out, make it equal to 0, and see what you can do. So we're going to multiply this out, and this would be x squared, and you would have plus 3x minus 2x minus 6 equals 84. So x squared minus, or plus x, sorry about that, minus 90 is equal to 0. My x got lost in this translation. That's bad. Here we go. Now we have it equal to 0, and we say, oh, hey, it's a lead coefficient of a 1. We would put an x here and an x there, and say what multiplies to negative 90 and adds to an understood 1. Now, if you hate factoring, right, unless your teacher tells you to use a specific method, run it on the quadratic formula, all right? So, or the quadratic equation, if that's what you're calling it. So what multiplies to 90 and adds to 10? How about 9 and 10? Now I want it to add to a positive 1, and it has to multiply to a negative 90, so they're different signs. And I'd have a plus 10 and a minus 9. So either x plus 10 is 0, or x minus 9 is 0, x is 9, x is minus 10. Now, if x was minus 10 was the correct answer, you would say, well, one of the sides is x plus 3, so that'd be minus 10 plus 3. This would be a side of negative 7, and we can't have a negative 7 dimension for a rectangle. How do you have a side that's negative 7 long? So this one is not feasible. If x is 10, x plus 3 would be 9 plus 3, so this would be 12. And if x is 9, x minus 2 would be 9 minus 2. This would be 7. So I'm thinking the dimensions are 7 and 12. Now let's talk about this for a second. A couple of things to watch out for. So you read it, got a general idea. You read it again and said, okay, it's an area. What do I know about the area? And now we're going to read it again and see if we can mentally check this and see if we're correct. So it says the area is 84. All right, so that says if I take these two sides, 7 and 12, and multiply them together, I should end up with 84. Is that true? Yes, it is. Now, if you went 7 by 12, it kind of looks good, but do you think you're going to get full credit for this? And the answer is no. All right, the reason you're not going to get full credit for this is they actually gave you units. This is not inches, it's not meters, it's not miles. So if it has units in it, you need to be sure that your answer has units in it, otherwise you'll be partially wrong. So this is 7 centimeters and 12 centimeters, and this is your final answer, 7 centimeters by 12. Now, maybe you don't want to do the 7 and then the little x for by 12. You know, if they just have like blanks over to the right for you to fill in, then you could just fill in the 7 and the 12. All right? And apparently my computer, there you go, is not going to let me put the x in there. There we go. That's better. Let's do another one. And this says the sum of the squares of two consecutive even integers is 164. What are the two integers? Well, okay, this might be new, right? Let's talk about consecutive integers. I'm going to go up here for just a second. So there's plain old consecutive, and then there's consecutive, even, or odd. Right. Now, consecutive integers are something like 1, 2, let's just list them next to each other. 1, 2, 3, 4. These are consecutive, one right after the other. If you went backwards, it would look like this. So that's really the number line, isn't it? The number line that we've been doing. So consecutive integers are just one number right next to the other. And how far apart are these integers from each other? Maybe it's easier to tell over here on the positive side. So you'd add 1 to get 2, add 1 to get 3, add 1 to get 4. So they're each 1 away from the one before it. So wherever you are, wherever x is, let's say it's 2, the next consecutive integer would be 1 away, which if this was 2, 2 plus 1 is 3. The next one would be 2. You go back to this one, all right? And 2 plus 2 is 4, x plus 3, and you go back to this one because you're looking at x. 3 plus 2 is 5. So do you see how each one of these consecutive numbers is one more than the previous one? So the first one's x, next one's 1 more, next one's 2 more, next one's 3 more from the original number, okay? And if they wanted, 6 consecutive numbers, you would keep going until you got to 6 listed. Now let's talk about even or odd. So if you had 0, 2, 4, 6, 8, and so forth, negatives on this side. Let's look over here. What's the distance in between each integer? And consecutive just means the next one, right? So I'm not wanting the next number, I'm wanting the next even number. So between 2 and 4 is 2. Then there's another 2 between 4 and 6, and another 2 between 6 and 8. So if my first one was 2, the next number is 2 over. So here's 2. The next one is 2 over from that is 4. The next one from x, from the 2, is 4 over from 2, right? Because you go back to the original. The next one would be 2 more over from that, so you would have 6. So you go back to x, and this would be 8. So 2, 4, 6, 8. So you start with x. Then your next consecutive even would be x plus 2. Your next consecutive even would be x plus 4. Does that make sense? Let's talk about odd. So if you had odd, let's look at some odd numbers. You would have 1, 3, 5, 7, so forth, right? -1, -2, not -2, -3, -5, right? So let's look right here. So 1, how far do you have to go to get to 3? 2. And then 2 more to get to 5, and then 2 more to get to 7. So if you look at it, this x plus 2, x plus 4, and x plus 6 works for the odd ones as well. If this was 3 where let's start with 1. because we'll run out of room. If we start with 1, the first number is 1. 2 more than x would be 3. 4 more than x, so 4 more than 1 would be 5. 6 more than x would be 6 plus 1 is 7. So you see how you have 1, 3, 5, and 7? So here you go. If you have plain old consecutive, the first number you don't know is x. The next one's x plus 1, x plus 2, x plus 3. Each one of these increases by 1. If they say even or odd, then the first one's x, x plus 2, x plus 4, x plus 6. And how do you turn out with even numbers versus odd numbers? By the information they give you. All right, what they multiply to or add to or whatever they're talking about, what's going to happen with them, that will make it turn out to be even or odd. So they work these out before you do it. Okay, now this says the sum of the squares of 2 consecutive even integers is 164. What are the 2 integers? So you go, okay, wait, consecutive even integers. So this is saying they're in a line, but they're even. So the first number, and some teachers will say, let's let x equal the first number. And that's a good practice. Not all teachers make you say let x equals. If that's the first number, and you may want to be specific and say it's the first even integer, the next one is going to be 2 over from wherever the first one is. So this would be the second. And we don't have to have a third or a fourth. We just had 2. So this is all I have to name. So the first integer is x, the next one's 2 more. So it says the sum of the squares of 2 consecutive even integers is 164. Okay, so I've named these 2 consecutive integers, and now I'm going to square them. So x squared, and the sum means to add. It's 164. All right, now does that look good? Because this is, if we're going to make an arrow, this is most likely where it's going to happen. So let's read it again. The sum, yes, I added. Squares, okay, square. 2 consecutive even integers. Okay, even is x and x plus 2. Okay, I think that's right. So be sure you spend 30 more seconds just to reread and double check. Now, I don't know what adds up to 164, so the only thing I'm going to try to do is get it equal to 0, because then I can factor it, quadratic formula, whatever you want to do. So x squared. X plus 2 squared is not x squared plus 4, okay, because that's a binomial. And so what you have is x plus 2 times x plus 2. So this is x squared plus 2x plus another 2x is 4x plus 4. And so if you're missing this 4x term, every teacher knows what you did. You went, oh, let's just square the x and the 2. And just as a reminder, if you had a monomial, this is a monomial, and you squared it, you'd square the 2, and you'd square the x, and you'd be done. But that only works on monomials. It does not work on binomials. So this is equal to 164. Now let's try to get it equal to 0. So I have 2x squared plus 4x. Let's see, minus 160 is 0. So I can factor out a 2 and make it a little easier. And I like factoring better than I like that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to keep factoring. So I have my 2. And I have a lead coefficient of a 1. And I want to know what multiplies to negative 80 and adds to 2. Have you already figured it out? How about 10 and 8? So I'd want a plus 10 and a minus 8. But again, if you'd rather use completing the square, or you would rather use the quadratic formula or equation, that's fine. So 2 cannot be 0, because 2 is a 2. X plus 10 might actually be 0 if x was negative 10. And x minus 8 might be 0 if x was 8. All right. Now, can you tell already, kind of looking back, if you have x plus 10, that this is going to solve out to negative 10, and x minus 8 is going to solve out to 8? Because probably in the next group or two, we're going to start shortcutting this step right here. So I just want to kind of give you a heads up. Now let's look at this again and go, wait, what are we finding? Because over here, I discarded the negative numbers saying, okay, I can't have the negatives. But that was because it was the length of a side, and we don't have negative numbers for lengths of sides. However, I can have negative integers. I had some up here, right? So a negative integer is, a legitimate answer. Let's try what we can do next. So this is saying there's two possibilities for the first number because x is the first number. So if x is negative 10, x plus 2 would be the next even number. So you would take this negative 10 and put it in place of x. And this one would be negative 8. Okay, so I'd have negative 10 and negative 8. All right, is this true? Are the sum of the squares of these two integers 164? All right, what's negative 10 squared? Wouldn't that be 100? And what's negative 8 squared? Isn't that 64? And yeah, that's 164. All right, so depending on your teacher and the computer, if you're doing computerized homework, they may let you just put in negative 10 and negative 8, or they could say they want x is negative 10, x plus 2 is negative 8. You would know which format you need to use in your class. Now, if x is 8, the next number is 2 more than that, so it's 10. So probably no surprise here. It's the positive versions of these. All right. There we go. Let's do another one. Okay, this says the lengths of the sides of a right triangle are consecutive integers. What are the lengths of the sides? So you go, okay, this is a triangle problem. All right. And it has three sides on a triangle, and it doesn't say anything about them, like this one over here gave us dimensions. This one doesn't give us dimensions. It gives us information. And it says the lengths of the sides are consecutive integers, not even or odd, but just plain old consecutive. So I know that one of them's x, one of them's x plus 1, and one of them's x plus 2, because that's how it works for three consecutive generic numbers. And you look at it and go, does it matter which one of these sides over here is x versus x plus 1 and versus x plus 2? Yes, it does. All right, because if you have a right triangle, the longest side is this one right here, right? That's called the hypotenuse. And the hypotenuse has to have the biggest number. All right? So this one would have to be x plus 2. Now, where do the other ones go? It doesn't matter. Okay? But the longest one has to have the biggest number. And if you add 2 to this number, that would make it the bigger number. Because we're not doing negatives, remember, because we don't have negative sides. So if you're having to name these and call them something, you would say let x equal one side, or you could call it one leg. Remember that the two legs off of this right triangle, they called them legs. This would be the second leg. And this would be the hypotenuse. I can't spell. I just told myself to spell that right. Hypotenuse. I can actually spell. I just got lost for a minute. Okay, so let's just make this, I don't know, let's make this x and this x plus 1. Now, so we've labeled everything and it says, what are the lengths of the sides? Well, okay, I need some sort of math equation. Now, what do I know about right triangles? I know the area is 1/2 the base times the height. I know there's 180 degrees inside of a triangle. I know that the right part here, this squared off part right there, is 90 degrees. Now, is that anything pertinent to what they said? Did they say anything about the area? Did they say anything about the angles? No, they did not. They just talked about the lengths of the sides. Okay, what do I know about the lengths of the sides of a right triangle? Well, in your past, you may have learned something that went a squared plus b squared is equal to c squared, right? The sum of the squares of the two legs is equal to the square of the hypotenuse. So let's try that. Okay, so if we do that, we would have x squared plus x plus 1 squared is equal to x plus 2 squared, because the longest side, the hypotenuse, has to be on one side of the equation, and the other side of the equation gets the two shorter sides. That's what's important here, or you're going to end up with negatives. All right, so this is x squared. X plus 1 squared, remember, we have to write it down twice and FOIL it out, is x squared plus 2x plus 1. And x plus 2 squared is x squared plus 4x plus 4. Now, I just put parentheses right here just so that you can see where we came from. Now, what I want to do is try to get everybody on one side and make it equal to 0. So when I get everything over to the left side, I have x squared minus 2x minus 3 is equal to 0. So again, I like factoring. Right, what multiplies to negative 3 and adds to negative 2? How about negative 3 plus 1? So x minus 3 is 0, or x plus 1 is 0. X is negative 1. X is 3. Now, can I have a side, because this negative 1 says that this side right here would be negative 1. Can I have a side that's a negative length? No. So this one's out. Right? Now, can I have a side that's 3? Yes. So if x, which is this left side, is 3, the bottom side is 1 bigger, so that'd be 4, and the hypotenuse would be 2 bigger than the original, so 2 plus 3 is 5. Now, did they say dimensions like meters or inches or anything? No, they did not. So I'm thinking this is my answer, but let's see. Would that work if I have a right triangle like this, and this is 3, 4, 5, does 3 squared plus 4 squared equal 5 squared? Well, does 9 plus 16 equal 25? Yes, it does. So these are my three sides. Alrighty, let's do another one. This one seems to be a popular one. It's related actually to this one, all right, but it doesn't necessarily read that way. And it says one car travels north from an intersection while another car travels east from the same intersection. If they leave the intersection at the same time and one travels 7 miles per hour faster than the other, find the speeds of the two cars if in 1 hour they are 17 miles apart. Okay, so here's my intersection. Somebody's going to travel north. Somebody's going to travel east. Okay, now, if they leave the intersection at the same time and one travels 7 miles per hour faster than the other, find the speeds of the two cars if in 1 hour they are 17 miles apart. So this is the 17. All right. Now, what they're doing, can you hear it? They're saying one is 7 miles per hour faster. So if they're saying faster or slower, they're talking about speeds. How fast are you traveling? And you know that the distance that you can travel is equal to your rate or your speed times your time. So that if you were traveling 60 miles an hour for 2 hours, 60 miles per hour times 2 hours would be 120 miles, right? So if this is 17 miles that they're apart, okay, and I'm trying to also relate how fast they're traveling to get there, because that's what they told me about their respective size. They didn't give me distances, they told me how fast they were going. So it says one travels 7 miles per hour faster than the other. So if this one was going x, this one is going x plus 7. But this one is a distance. 17 is a distance, and x plus 7 are rates. So how do we get from rates to distance? We multiply by time. So x plus 7 is a rate times the time, which is 1 hour, would be some distance. And this x, which is a rate, times its time, which is 1 hour, would be a distance. Okay, so x times 1 plus x plus 7 times 1. Now, what do we know from over here about the sides of a triangle? The squares of the two legs. So this x times 1 squared plus this x plus 7 squared is equal to 17 squared. Now, if they had been traveling for 2 hours, you would put 2's there. If it was a half an hour, you would put 0.5 for half an hour. Okay. Now, or if they said 30 minutes, it'd be still half an hour, right? So x times 1 is x. This would be x squared. X plus 7 times 1 is x plus 7. X plus 7 squared is x squared plus 14x plus 49 equals, and 17 squared is 289. So 2x squared plus 14x minus 240 equals 0. So 2 times x squared plus 7x minus 120, factoring out my 2 in common. What multiplies to 120 and adds to 7? How about a minus 8 and a plus 15? Does that work for you? So the 2 cannot be equal to 0. X minus 8 might be equal to 0, in which case this is equal to 8. And x plus 15 could be equal to 0, in which case this would be negative 15. And what that's saying is, remember, x is my rate. So you could be traveling 8 miles an hour or a negative 15 miles an hour. What do you think? So I'm thinking it's 8. Now, if I just box in 8, am I going to get full credit? No, because up here they're talking about speed and miles, so they did give me some units. You could say mph for miles per hour, but you have to say something. And then the other one is 7 miles per hour faster. So x plus 7 would be 15. And you could check these by setting up your little triangle, like over here, and seeing if the sum of the squares of the legs equals the square of the hypotenuse. Let's keep going. So you check that, all right? And it says the height in feet of an object dropped from the top of a 256-foot tall building is given by, and there's the equation, minus 16t squared plus 256, where t represents the time in seconds after it is dropped. How long will it take to hit the ground? Okay, so I have h of t is equal to minus 16t squared plus 256. So h is the height, t represents time, and the question is how long? So they want you to find t. So they want you to identify what t is equal to when it hits the ground. Well, if h is the height, what is the height when it hits the ground? Would it be 0 because it'd be at ground level? So 0 is equal to minus 16 t squared plus 256. Now you could do this in one of two ways, really. You could say, all right, I'm going to move the 16t squared over here. You could factor this as well. Okay, then I'm going to square root both sides, and I'd have 4t. And over here it's plus or minus 16. So t is plus or minus 16 over 4. T is 4, plus or minus. Now, let's talk about that. T represents time. Can you have a negative 4 seconds? No. So T is 4. Don't forget your units. It could be minutes or hours. So that would work. Now, could you do this? 16t squared is equal to 256. Divide both sides by 16 right now. So t squared is equal to 16. Square root both sides. T is equal to plus or minus 4. Yes, either way works. You're still going to get 4 seconds. Or, you could try to factor it. But I just wanted to show you something kind of different. So those are some examples of how this would work with story problems, otherwise known as applications. This is going to be the last of the videos on just quadratics. We're going to start applying them in future videos and moving into graphing and all sorts of neat and cool things like increasing and decreasing and domains and ranges. So see you at the next video.